Pythagoras Theorem defines a relationship between the angles and sides of a right-angled triangle. Elements of Pythagoras Theorem is used in science, engineering and design for many purposes. Some examples include triangulated structural calculations, vectors and even friction. As Pythagoras Theorem deals with right-angled triangles, we always start with one known angle at 90 degrees. For triangles, the three angles combined will add up to 180 degrees. Therefore, the two missing angles will equal 90 degrees. The longest side is known as the hypotenuse. The remaining sides are labelled the adjacent and the opposite. The hypotenuse is always considered the longest side. However, the adjacent and opposite faces swap depending on which sides and angles are known. The relationship between opposite and adjacent sides centres around the available angle. For instance, if angle B is known, the side next to the angle, in this case side A, will be considered the adjacent. The side directly opposite angle B, shown here as side B, becomes the opposite. Side C, therefore, being the hypotenuse. If our reference angle is A, then side B becomes the adjacent via connection to angle A, whereas side A is considered the opposite to angle A. Sohcahtoa is a useful method of remembering how to calculate the unknown sides and angles. The first part, SO, represents the sine of the angle which equals the opposite over the hypotenuse. We can use SO only if one of the sides is opposite the angle. We can use the calculation when we know either side, both sides, or 1 plus the angle. CAH represents the cosine of the angle equaling the adjacent over the hypotenuse. CAH can only be used if one of the sides is connected or adjacent to the angle. TOA represents the tangent of the angle equaling the opposite over the adjacent. We need opposite and adjacent sides to calculate the angle. We can pick and choose which calculation to use depending on the available information. Let's apply the theory to some worked examples. In the first example, angle B is needed and sides B and C are known. Side B is opposite angle B. Side C must be the hypotenuse, as it is both the longest length and opposite the 90-degree angle, or angle C. Opposite and hypotenuse sides indicate the sine rule should be used. Opposite over hypotenuse equals side B over C. To find angle B rather than the sine of it, we need to expand the equation. Therefore, apply the inverse of sine to B over C. This gives 30 degrees for angle B. If angle B is known and side B is needed, SO is still appropriate. Side B remains the opposite. The main difference here is sine angle B is known. If side B over hypotenuse equals sine 30 degrees, then the equation can be rearranged so side B equals sine 30 degrees times 57.74. Side B is therefore 28.87. Let's try a different example based on the CAH relationship. As in the previous example, our knowns are angle B and side C, but this time we are looking for side A. Side C is, as always, the hypotenuse. Side A is adjacent to angle B. This leads us to the cosine adjacent hypotenuse relationship. This equation looks familiar. We've seen this kind of arrangement in example 2. Cosine angle B equals side A over hypotenuse, or side C. Rearranging gives side A equaling cosine 30 times 57.74. Side A equals 50. Let's try another example. Example 4. This time, angle B and side B are the only knowns. Again, we need side A. This time, the tangent, opposite, and adjacent relationship can be used, or TOA. Side B is opposite angle B. Side A is adjacent. Tangent angle B equals side B over side A. This means tangent 30 degrees equals 28.87 over side A. This time the side we require is the dividing factor, so rearrangement means tangent 30 becoming the dividing factor. Side A therefore equals 28.87 over tangent 30. Side A therefore equals 50. In example 5, there are occasions when only sides are known. Here, none of the Sohcahtoa principles are appropriate, but for right-angled triangles, the sides can be used to calculate one another. Side A is calculable by the square root of side C squared minus side B squared. Side A equaling the square root of 57.74 squared minus 28.87 squared. Side A equals 50. Example 6. Side B is calculable by the square root of side C squared minus side A squared. Side B equaling the square root of 57.74 squared minus 50 squared. Side B equals 28.87. Example 7. Finally, side C is calculable by the square root of side A squared plus side B squared. Side C equaling the square root of 50 squared plus 28.87 squared. Side C equals 57.74. To summarise, when any two sides are known, there are two missing angles and one side. The table shows a breakdown of the basic equations for each variable. When any one angle and side is known, there are two missing sides and one angle. This table shows a summary of the basic equations for each variable.